Over the last few days, I've been thinking about going over to lithium based batteries for off grid storage in the shed, and several options have come up. I was thinking about maybe ordering LifePo 4 from Power, and this seems like a reasonably good option. In total, it was going to cost me for 16 of these cells, so I can make up a 25.6 volt 400 amp hour bank. It would cost £3,408, and that's quite a lot, but that'd only give me about 10.2 kilowatt hours. So, and plus it's coming over from Germany, so I'm not sure if I'd face an enormous VAT and customs charge, so I'm thinking about maybe avoiding this option. I saw this option, I use Nissan Leaf battery, but unfortunately the guy doesn't want to deliver it, so there's no delivery option on that one, and that would have been brilliant because the cells are all bolted together. I could unbolt them and I could have a huge off-grid storage bank. The current one I've got is only 6 kilowatt hours and it's lead acid, and I want to move away from lead acid because it does waste a bit of energy when charging, and you'll damage lead acid. It won't last as long when you're discharging it deeply, and I never have this deeply discharged my batteries. So what I'd hopefully like to do is sell my bank off for £200. It was about just over £400 when I got it. The option that I'm really considering is this. It's a 12 kilowatt hour battery, and it came out of a Mitsubishi Outlander, and it's more energy storage, plus it's cheaper than going for the Power batteries from Germany, and the cells inside this are all bolted together, so I'm thinking about maybe going for this, and hopefully it'll be in good condition and everything, and if not, well, hopefully the sales will good act. You could hit them with that, but it should be okay. So this is what I'm probably thinking about. I'll take all the cells out of it, just link them up in parallel series and make up a huge bank. The thing I don't like about LifePo 4 is you can't really accurately know the state of charge by voltage. Once you charge it up, it's similar to lead acid, its voltage will rise up to, you take it up to 3.6 per cell, and then it will drop down again when you take it off charge to about, I think it's roughly 3.4. So you haven't really much of an idea really. So whether it's at 50% or 100% fully charged, there's not very much voltage difference to go by. But with lithium ion here, I'll be able to know, because when the cells are fully charged, they're at 4.2 volts, and they stay there and only drop down due to self-discharge over a very long period of time. But I'll never be charging them up to 4.2 volts. I'll probably go for maybe 3.95 or 4, so I can have a huge amount of safety headroom. So this is the option I'm most likely going to go for, but I'm not sure yet, as it is a lot of money. As for battery management, I'm fairly confident that I'll be able to make a system up out of Arduinos. I would have one Arduino on each block of parallel cells, and it'll be powered by itself off the block, and when the voltage gets up to a certain voltage, I'll trigger a MOSFET, discharge into a resistor, and then it'll come off when the voltage drops again. It should be very simple to do. You'd only be able to do it in a few lines of code. But I'll make a video if I do buy this. I don't know if I will though, it's a lot of money. So I'd just like to add another reason why I would benefit greatly from lithium. In the winter I don't use my grid tie inverter at all. Well, I've put it on today, but sometimes in winter the batteries will be sitting fully charged, and then that's obviously power that the solar panels are not producing, because with the batteries fully charged, the solar panels can't be supplying the amount of power they could be. So with lithium I could be connecting up the car to them, charging up the car off the lithium batteries at night, or feeding back power into the grid at 5 o'clock when power demand is at its greatest. And also in the summer, the way my system works is with the grid tie inverter. When it gets to a certain voltage, it'll automatically cut off. I've got a system that controls that, but in summer the voltage will rise up really quickly. Then the inverter takes just a little while to get back up to full power again, and during that time that's also energy that's getting wasted. But with a lithium based battery, they can absorb huge amounts of power, and it takes quite a while for the voltage to rise up. Lead acid, the voltage rises and drops pretty fast unless you have a really massive bank. So I think lithium would be a really good option, but it's very expensive, and I'm not quite sure about it at the moment. But the benefits are quite obvious. Plus, they are more eco-friendly than lead acid. Although lead acid can be recycled, it does take a lot of energy to produce them in the first place and then recycle them. I was looking at the life cycle of lead acid, and you get about 2 times as much energy out of a lead acid battery as was used to create it. And with lithium, I think that's about 10 times greater. So you've got basically they handle more energy. They can discharge more energy out of them over their lifetime of charging and discharging them than was used to create them. That's what that means.